Hello, AI enthusiasts. Welcome to a new deep dive. Building on our previous talk about the bias-variance trade-off, most videos on machine learning explain complexity as just a number of parameters. In this video, we want to show something different: the actual physical capacity of a model to absorb information, much like the mental capacity of a student preparing for an exam. By the end of this video, you will finally understand how to find the perfect balance between a model that is too simple and one that is too complex. Imagine a student who only learns one single fact for a massive history exam. This represents low model capacity. No matter how much data you show it, the model is too rigid to learn the underlying patterns. In machine learning, this is underfitting. We see this when a straight line tries to fit a curved set of data points, missing the nuances entirely because its brain simply isn't big enough to hold the complexity. Now, consider the opposite extreme: a student who memorizes every single comma and sneeze in the textbook, but fails to understand the actual history. This is high model capacity gone wrong. The model has so much room to store information that it memorizes the noise and the random spikes in your data. When we look at a complex polynomial weaving through every single outlier, we are seeing a model that has lost the ability to generalize to new, unseen questions. The ideal student learns the core concepts that apply to any question. This is the sweet spot of model capacity. Think of it like a tailor making a suit. If the suit is just a box, it fits no one. If it is sewn exactly to one person's posture, it won't fit them later. We want a model that captures the essence of the data, the smooth curve, without getting distracted by temporary fluctuations in the training set. We can visualize this capacity using the degree of a polynomial. A degree 1 polynomial is just a straight line, representing very low capacity. As we increase the degree, the line gains the flexibility to bend and twist, like a student adding more and more specialized tools to their kit. However, notice how the edges of the graph start to swing wildly. This extra flexibility is a double-edged sword that creates unpredictable behavior. There is a measurable gap between how a model performs on what it has seen versus what is new. Think of it as the difference between a student's practice scores and their performance on the actual unseen exam. This U-shaped curve is the ultimate guide. Our goal is to find the bottom of that valley where the model is complex but remains useful. To summarize, model capacity is the fundamental limit on what your machine learning system can learn. Too little capacity leads to underfitting. The key is to be like the student who understands the concepts rather than the one who either ignores the data or memorizes the noise. By understanding this relationship, you can build models that truly understand the world. Thank you for joining us in exploring this delicate balance. Subscribe for more deep dives into model complexity.